Hello. In this example, we're going to find all asymptotes for each function. Now, if you look at A, f of x equals x plus 1 all over 2x minus 1 times x plus 3. If I want to find asymptotes, I'm going to start with vertical asymptotes. For vertical asymptotes, abbreviated VA, we set the denominator equal to 0. So that gives me 2x minus 1 times x plus 3. Set that equal to 0. Now notice that I would factor this if I could, but it's already factored, so I set each of these equal to 0, which means 2x minus 1 equals 0, or x plus 3 equals 0. Add 1, divide by 2, so x is 1/2, subtract 3, so x is negative 3. So x can be either negative 3 or x is equal to a half. These are your vertical asymptotes. And yes, you do have to put x equals for each of these. Now notice that I'm not putting curly brackets around these because these aren't really solutions to equations. What these are the actual equations of the vertical asymptote. Okay. Now, the next we need to find is the horizontal asymptote. To find the horizontal asymptote, well, you have to look at the degrees. The degree of the numerator is 1 because there's an understood 1 on that x there. Now, there's an understood 1 here and a 1 here for the denominator, so you have to add the multiplicities here, so 1 plus 1 is 2. So the degree of the numerator is 2, the degree of the denominator is, the degree of the numerator is 1, the degree of the denominator is 2. Notice that 1 is less than 2. So because 1's less than 2, we have a horizontal asymptote, and it is y equals 0. A lot of people find this confusing for the degrees. I will show how to kind of see this later, but just know that when the degree of the numerator is less than the denominator, it's y equals 0. When the degree of the numerator equals the degree of the denominator, it's y equals a ratio of the leading coefficients. And if the degree of the numerator is greater than the degree of the denominator, there isn't a horizontal asymptote. Okay, let's look at B. F of x equals 2x plus 1 over x minus 3. Now this time, to find the vertical asymptote, we're going to do the same thing. Set the denominator equal to 0 and solve. Add 3 to both sides. Fantastic, x equals 3. Now, let's look at the horizontal asymptote. The horizontal asymptote is dealing with the degrees of the numerator and denominator. The degree of the numerator is 1 because there's an understood 1 right here for the x, and the degree of the denominator is 1 because again there's an understood 1 right there for the x. They're the exponents. Because 1 equals 1, they're the same degree, we have to look at the ratio of the leading coefficients. The leading coefficient in the numerator is 2, and the leading coefficient in the denominator is 1. So you're just going to have to simplify, and that's going to give me y equals 2 for my horizontal asymptote. For C, again, the vertical asymptote, we set the denominator equal to 0. X minus 2 equals 0. Add 2 to both sides, so x equals 2 is the vertical asymptote. Then we look at the horizontal asymptote. We're going to look at the ratio, we're going to look at the degrees of the numerator and denominator. The degree of the numerator is 2, the degree of the denominator is 1. So because 2's greater than 1, there is no horizontal asymptote. It's technically an oblique asymptote, specifically a linear asymptote. Now let's see what this looks like, and let's try and figure out why this occurs the way it does. I want you to look at C here. notice that we have a polynomial divided by x minus a number. I'm just going to find a decent color here. Let's use orange. How about that? Okay. I'm going to actually synthetically divide here. Oops. And we have a x minus 2 in the denominator. That makes a 2 synthetically divide here. So that's 1, 0, 1. Now notice that I have a 0 here because I'm missing a degree. Bring down, multiply, add, multiply, add. Fantastic. Now, if I was to write this down, x squared plus 1 all over x minus 2, in this form from down here, that would be x plus 2 plus 5 divided by x minus 2. Let's look at b. Let's synthetically divide this here. So that gives me a 3 here. Synthetically divide, we have the 2 and the 1. So I bring down the 2, multiply, and add. And this is the remainder here. So what this would be 2, because it's just the only thing here, plus the 7 divided by x minus 3. Now let's look at a. Look at the degree of the numerator. It's 1. The degree of the denominator is 2. And if I was to multiply this out, this would look like x plus 1 divided by 2x squared plus 5x minus 3. I want you to realize something. As x gets really, 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 really large, or really, 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 really small, all of this just goes to 0 here for a. And the reason why is because, let's just say x was 1,000,000. Well, you have 1,000,000 in the denominator, but then you have 2,000,000,000,000 in the denominator. In other words, what's that, 2 trillion? So you would have 2 trillion in the denominator. So 1,000,000 divided by 2 trillion is 1 2 trillionths, or sorry, 1 2 millionths. And that's only at 1,000,000. Let's go to 1,000,000,000. Well, you'd have 1,000,000,000 in the numerator and 1,000,000,000,000 in the denominator. That's getting really, really, really small. So all of this is going to 0. Over here, the same thing is happening for each of these. This goes to 0, and this goes to 0. So all of this goes to 0, all of this goes to 0, and all of that goes to 0. So because of that, look what's left. There's nothing left here. Oh, look, that's why you have y equals 0. Here, what you have left is a 2. Fantastic, that's why you have a horizontal asymptote of y equals 2. Here, it's y equals x plus 2. In fact, your oblique asymptote, if you wanted to write it down, would be y equals x plus 2. Notice, though, that there is no horizontal asymptote. If there's an oblique asymptote, there's no horizontal, and vice versa. But this is how you figure it out. It's effectively what's the function approaching as x gets really, really, really large. Okay, and this line is what it's approaching here. Now, these are both lines as well, but they're horizontal lines. Alrighty, well, I hope that helped clear things up for you a little bit. I do want you to realize if there was a 3 in the numerator and a 2 in the denominator, you'd still have a linear function, because 3 minus 2 is 1. Or if you had 3 in the numerator and a 1 in the denominator for the degrees, then this function over here would be quadratic. That's just how rational functions work. Alrighty, well, I hope this helped clear some things up for you, and I hope it helps you understand how to find vertical asymptotes and horizontal asymptotes. Alrighty, well, we'll see you in the next video. Have fun!